So there are certain like basic key concepts that we got to understand about the circle theorem. Now, the first key concept is that, look, like there are certain key terms. First, you need to understand that if you're drawing a tangent at any given point on the circle, so this is your tangent line. Uh, any point within the circle is referred as interior points on the circle, and any point which is outside is referred as exterior. So the first property that you got to understand is very important is basically when you have, let's say, a radius, and if you join the point of contact with the tangent. So when you're joining the point of contact with this tangent, you will notice that this angle that you got here is a right angle triangle, always. So you, irrespective of any amount of triangles that you draw, I mean the tangents that you draw, it will always be that this angle that you're joining will be always perpendicular to any tangent. So, so here, if I have a point of contact, if I join with the radius, it'll be right angle. Anywhere you see, it'll be always a right angle. So the first property is that a tangent and radius at the point of contact, they create a right angle. So that's number one. This can be very like, handy in terms of doing some geometry questions. The second property that we have is, indeed, like this is very common, this thing. If I have got, let's say, if I'm moving this external point of contact, so from an external point, you can draw two tangents on a circle. They both create an isosceles triangle together. So if I have, let's say this, if I join this side, let's say here, um, with this, it'll form an isosceles triangle. So these two measurements from an external point will always be the same. So this angle that you get, suppose it is x, this angle is also x because they are isosceles triangle. So equal lengths are basically from the point of contact to the external point. So this is the point of contact, and from here to here, and this length from here to here will always be the same. Irrespective of any points you move to, you will notice that that length is always geometrically same. You can see that. So these are the two basic properties. Now, coming to the next parts, like, which are basically, the first one is basically the angle in a semicircle. So when you talk about the angle in a semicircle, so let's say here, if you look at, here, if you look at the basic part, so first thing is that if you have end point on the diameter, so if you join this with any point on the circle or on circumference, this will always create a right angle. So you'll notice that wherever I join this point with the end points of diameter, it will always create an angle that is a right angle basically. So this is very important property, has been assessed several times. Let's just have a visual look at this. You can clearly see if I drag the slider here, it is not changing its position. Here also you can see that angle is always right angle in a semicircle. So that's one thing. Angle in a semicircle is right angle. Remember that if this point is not the diameter, if this line is not the diameter, segment is not the diameter, then this angle won't be 90 degrees. Sometimes like people think that, okay, this, if I join this with like here or something like this, even this is right angle. No, as long as this side is not a diameter, it won't be a right angle. So that's your number two. Next property is the cyclic quadrilateral. So whenever you're talking about the cyclic quadrilateral, so in cyclic quadrilateral, basically, cyclic quadrilateral is something where you can see that all the four vertices, A, B, C, and D, of the quadrilateral lie along a circle. So if any of the point is not on the circle, like if sometimes the point you see is something like this is not a cyclic quadrilateral anymore. If I join this, the pink one, you see it's not a cyclic. But only if all the four vertices are on the circle, then only it will form a cyclic quadrilateral, like out here you can see. Now, so what is the so unique property about cyclic quadrilateral is basically always remember that opposite angle of a cyclic quadrilateral add up to 180. So you notice that if I have got this angle, 113, this is 67. So they both are always opposite angles, always add up to 180. Same with here. You can see that these two angles, which is 96 and this is 84, the 96 and 84 adds up to basically 180. So this is the exact outcome of the cyclic quadrilateral theorem. So here, like anywhere you move these points, you'll notice that even though individual angles change, you'll notice that the sum is always 180 for opposite angles. So you can see here 93 and 87, 180, 68 and 112, 180. So this is how you tackle the cyclic quadrilateral. Next is this we already discussed, that anywhere you take the point of contact, it is always going to be a right angle. So this is we already have discussed point of contact and all. Now these three properties that I'm discussing now is very important. So the first property that we have is, so let's say angle on the same segment. Now firstly, before we do this, you got to understand what is a segment. So let's say if you pick up a segment, for me, I pick up this, let's say this segment. If I join any 2 points on the circle, it creates two segments. One is a minor segment, that is this one, and one is a major segment, that is the other one, which is this side. So whenever you're finding out that if there are two angles are on the same segment, then the measurement of those angles is going to be the same. Now have a look at this example. Is if you look at this angle, which is 43, and this is also 43, these two angles are on the segment, this minor segment. So you can see that they are like actually created on the other side, or you can say other segment here. At the circle, it is must that these 2 points are on the circle. So if I have a point something like this, the measurement is not going to be 43 for this one. This is going to be different. So here what is important is that your points that you're taking is on the circle, and this two, if you say A, B, C, this is A, B, C, and this is, let's say, A, D, C. You'll notice that whenever the angle is on the same segment, A and C, A, D, and C, here also A and C seems to be common. So that indicates that angle are on the same segment. So this angle you see is created on this segment, as well as this angle is created on the segment, this segment. So angle on the same segment will always have the same measurement as long as these 2 points are on the circle. Similarly, if you look at this side, these two angles here and here, 31 and 31, these two angles are also on this segment. If you clearly see, if I take this as A, B, C, and D here, you'll also see that these two angles are on the segment AC. So the point here is that if anywhere I go, like if I could change the position also, you'll notice that the angle, this angle is 74, this is 74, but this is 43, this is 43. And if I change this position, you will notice that this is, if I look at the same property again from here, so this is the segment, and here this and these two angles are created on the same side. And at the same time, these 2 points are on the circle. That's important. Same way, when you look on the other side, you have this segment. So 74 and 74, and these two angles are created on this common segment, this segment. So that's why angle on the same segment will have the same equal measurement. So this is important. This is really, really important theorem that keep coming in exams. Just make sure that you understand this properly. Now here also, it's like pretty similar, that this is the new property that we have. So instead of, if you look at this context that we're discussing, is basically compared to the previous one, it's just like one step ahead. So here we saw that if the angle were on the same segment and if both the points were on the circle, their measurements are the same. So if this is 62, even this angle is going to be 62. Any angle that you create on this segment will always be 62 basically. All of these angles are going to be 62. Now, what is really interesting is that what if one of the angle that you have here, that is this one, is actually now, let's say, moved to the center. So in case if one of the angle is the center, this angle is going to be twice of this angle. Okay, so anywhere you can see that if I make this angle bigger, if I can make it smaller also, you can see accordingly this angles are changing. This is 48, this is 96. Even if I keep moving like this, you can see clearly whatever the angle that is at the, so it's a segment angle, segment is the same still. Okay, one is at the center, which is here, other is at the circumference. So the angle which is the circumference is going to be half the one which is at the center. So these are like, some of the instinctive points that you need to remember while you're doing circle theorem. Let's just kind of do some more like, logical reasoning. Here you can see this is 60, this is 120. So this is basically, I would say, if you remember, this can be linked up with the angle on the same segment, but one at the center, other at the circumference. So here, if I say these three conditions, this angle is going to be 60 because these both are on the same segment. The dotted segment is here. They both are on the same dotted segment, and here also they are on the same segment, but one at the center, other at the circumference. So the angle which is at the center is going to be double of the angle at the circumference. So if this is x, this is always going to be 2x. So this is important. This is needs to be understood. Coming to the last one, which is the alternate segment theorem, basically. So alternate segment theorem is very interesting. Now, here what we have is, let's say if you consider this as like one segment, so angle made, like here generally what I tell my students is that remember that there will be three chords, like you can say L1, L2, and then L3. So if you have three chords on a circle, then this theorem gets applied easily. So if you have got three chords, the angle made by one chord, which is this chord, and the tangent, that is this angle, is equals to the angle between other two chords. This is how I kind of take it as a shortcut. The angle made by one chord and the tangent is equals to the angle between other two chords, which is this one. Similarly, this side, angle between this tangent and this chord, which is 64, is same as the angle between other two chords. So this is how you basically look at the alternate segment theorem. Like, see, sometimes we look at angle in one created in one segment is same as angle in the alternate segment, which is this. So that's why this is also referred as alternate segment theorem. So if this angle is, let's say, 64, this angle is also 64. You can see that even though if I change the position of the, or position here, you can see still my angle, that is, you can see this is 87, this is 87, this is 36, this is 36. So you can see that even if I keep changing the positions, still you can see that the angles in the alternate segments are equal. So this is 78, this is 78, this is 39, this is 39. And here, like, only one thing you always remember is it must have a tangent and three chords, C1, C2, and C3. So angle between one tangent and one chord, tangent and the chord, is equals to the angle between other two chords. That's how you can remember. So this is referred as the alternate segment theorem. So these are the background information of about the circle theorem. Now let's kind of do some problem practice. So here what we have is we have got a particular question from this paper, which is 2017 paper 2 for international math. So the first question is, you have been given that ABCD is a cyclic quadrilateral and DC is extended in a way that it is cutting here at C and here it is at E. Angle BCE is 130, so this angle is 130. ABX is 6x, ADX is 9, so these are given. You have to find our angle ABD. Now, before we go ahead, just remember that ABCD is a cyclic quadrilateral. They have already written here. So angles of cyclic quadrilateral add up to 180. So first thing is that, see, this is 130, so this angle is going to be 50. So 50, and this is again going to be 130. So this is basically this angle is 130 BAD. Now for angle ABC, you got to use the again cyclic quadrilateral. So 9x plus 6x is basically 15x. This should be equals to 180 because opposite angles of a cyclic quadrilateral to 180. So you get the value of x, which is 180 divided by 15. So basically this is nothing but 12. So this x is 12 degrees. This is 12 and ABC will be 6 times 12, which is 72. This is about this particular question. Circle. Angle AOD is 140 and first angle you're asked is to calculate angle ACD. The angle ACD is this angle. Now, what I can say is that if you look at simply, if I take, let's say, a arbitrary construction here, so this angle is 70 degree because you can see that they're on the segment AD, one at the center, other at the circumference. So the angle which is at the circumference will be half of the angle at the center. So this is 140, this is going to be 70. So once you got this is 70, so this is now A, let's say if I take this as X, AX, DC, these form a cyclic quadrilateral. So this is going to be nothing but 110. So that's the answer. Otherwise, you could have done was this angle you could have found out, which is 220. And this angle will be half of this angle, which because angle at the segment AD, one at the center, other at the circumference. So there are multiple ways to do this part. Since we got this angle at 110, we put this. Now you have to get angle BAD. So if you combine this angle together, this angle is 135. So BAD, if you see here, it forms a cyclic quadrilateral with this. So BAD angle is this angle, which is these two add up to 180. So this is 135. So if I take this as x, so x plus 135 as 180. So x is basically nothing but 45. So that's the measurement of angle BAD. So here in this question, basically we have been asked to calculate the value of P and Q with the given angle is 75. So obviously angle ADB and angle ACB, they are on the same segment, which is here. So this angle is 75 on the same segment. So this is 75. And then angle EAB we have to find, which is Q. So these two angles are opposite angles of cyclic. So it will be Q plus 75 equals to 180. So that gives us Q is basically 105. So that's the answer for this particular question. So first question here is in the second subpart is basically angle CBD. CBD with the given information is that angle, this angle is DBE is 15 degrees. CAD is 35. If you clearly see angle CBD, that is this angle, and angle CAD, they are on the segment DC. So these two have the same measurements. This is 35, so this is also going to be 35. Once you get this angle, so basically this is total is 50 degrees. Angle CDE forms a cyclic quadrilateral. CDE is a cyclic quadrilateral with angle CBE. So CDE, angle CDE plus angle CBE, they form cyclic quadrilateral, which is going to be 180. So this angle is CBE's angle is basically 50 degrees. So angle CDE is going to be 130. So that's the answer for this particular question.